Hello, my name is Nurhisa Farida and I am studying computer science in Astana 18 University. Today I am going to present you the result of my internship at LLP Pavlodar Tire, where I developed a backend project called Telegram Crawler. The goal was to create an automated system for collecting and analyzing public Telegram messages as part of an OSINT, which means open source intelligence. Telegram is one of the most widely used platforms for open communication. Many interest groups, activists, and even suspicious communities use it regularly. However, manual data extraction is difficult due to some reasons, like anti-bot mechanisms, dynamic web pages, and lack of structured public APIs. And my goal was to build a backend tool that logs into TG State, a Telegram analytics site, extracts public group links, fetches up 10,000 messages per group using Telegram API, and saves data for further analysis. This diagram shows how the Telegram crawler works. First, the system uses browser automation to log it into TG state and collect public Telegram links. These links are collected then in CSV file. Then the Teleton API connects to Telegram and downloads up to 10,000 messages per group, along with metadata like reactions, mentions, photos, videos, and other information. And finally, all data is saved in JSON file and a PostgreSQL database for structured storage and future analysis. This architecture makes the system modular, scalable, and suitable for real OSINT tasks. The following stack was used for efficient and robust development. And what about tools and technologies used in my project? As the main programming language, I choose Python 3.10, Selenium and Splinter for browser automation, Teleton for Telegram API integration, PostgreSQL for relational storage, JSON for local backups and inspection, and all development was done in Visual Studio Code using Chrome with a persistent login session. TG State requires Telegram web login via browser, which is hard to automate. And to fix it, I used Splinter to visit TG State to click for signing in Telegram and waiting for user authorization. And to avoid repeated logins, I used persistent Chrome profile. This slide shows us main functions in my project. For example, first function is collect messages from chat. It takes a Telegram link and download messages asynchronously using the Teleton API. It can also optionally save the results to a JSON file. And get media type detects the type of content in each message, like photo, video, mentions, and other information. And this logic helps to organize and classify messages for future analysis. For example, distinguishing text-only chats from media-heavy groups. In this page, you can see the function called read links from CSV. It loads the Telegram group links collected earlier from TG State. First, it checks if the CSV file exists, and if not, it returns an empty list. And after checking the existence of CSV file, it reads the file and extracts only the values from the Telegram chat link column. And these links are later used as input for the main message collection function. So this script is essential for starting the parsing pipeline. Here we can also see the function called login to TG-State. It launches a Chrome browser with a persistent user profile. This way, the bot stays logged into the TG-State without needing to re-authenticate every time. And as I said in previous slide, get media type function using for collecting medias, videos, and other information from these chats. Here we also use very important functions. For example, save to CSV. This function saves all collected Telegram links into a time-stamped CSV file. Scroll to bottom function simulates a user scrolling the page to load more content, which is required since TG-State loads chats dynamically. And get chat links waits until all chat cards are fully loaded before parsing them. And together, these scripts allow the bot to reliably extract links from TG-State, just like a human user would use it. Here I demonstrated the data structure in JSON file. Each Telegram message is stored in a normalized JSON format. For example, we collect metadata like links in CSV files, forward source, and user status also, which are really valuable for OSINT and behavior profiling. This diagram shows the full flow of Telegram crawler pipeline. It starts from TG-State, where bot uses Selenium and Splinter for browser automation to log in to collect all Telegram links. These links are saved in a file called TG-Link CSV. Then the Telegram API used specifically Teleton library to download messages and metadata asynchronously. All collected data is stored in two places: JSON files for archiving and debugging, and PostgreSQL database for analytics, dashboards, and OSINT tasks. This structure keeps the system modular, scalable, and ready for future use like NLP or visualization. Here I also demonstrated one part of all links in our CSV file. To be honestly, I have many challenges and problems during this project. For example, TG-State uses anti-bot protection mechanisms and monitors behavior. To solve it, we used like random delays and adaptive waiting. Then media content such as photos, videos, stickers couldn't be easily stored or categorized. To solve it, we used functions like getMediaType to label all text, photos, and media content, and also Teleton API return messages with incomplete fields or missing metadata. And to solving all these challenges took many time, but in my opinion, I finished them very well. All the key components of Telegram crawler were built completely from scratch. I designed a modular project structure. Crawler is login and TG-State parsing via Splinter. Parser is asynchronous message collection via Teleton, and utils database connection, login, and configuration. I also implemented an error handling and retry system by automatic retries for API errors and safe parsing of incomplete messages. And the results of my project was that my project collected over 10,000 messages and detected some keywords like drugs and weed, and stored metadata-rich messages for OSINT. and identified user patterns and behaviors. And here you can see some part of the bad words which we found. The internship helped me grow in multiple ways. I mastered asynchronous Python programming and built resilient scripts for browser automation, normalized data into PostgreSQL database. And it wasn't just about writing code, it was about building something really important for my future field. And I'm really interested in developing my research projects that may be useful to maybe to government. And in conclusion, the Telegram crawler project demonstrates how browser automation, APIs, and structured storage can support real-world intelligence tasks. In the future, I plan to integrate NLP for message classification, build dashboards for interactive analysis, and explore cloud deployment for scalability. And thank you for your attention. Goodbye.